Now that we know what completing the square actually means, let's see how we can use this process to solve equations. And here is our first example. Let's observe it first. It is a quadratic equation. We see that by the highest power of 2, that has all three terms present, and these terms are aligned from the highest power to lowest. So second power variable, first power variable, and variable 0 power that turned into a 1, and that's the reason we don't see it now. 25 times 1 would be just 25. So I'm also noticing that there are only pluses between the terms in this equation. So referring to formulas of a square over sum and square over difference, I realize that it's a square over sum formula that I will be using. So let's observe the equation once again. And maybe we should start from the last term, b squared. Right now what we see is 25. So if we only could figure out which number to the second power, just like b squared, would give us 25, then just in case we would write it down. That of course would be b squared. This would mean that b itself is a 5 because it is the 5 squared that would give me 25 here. This means that I can rewrite this entire expression, breaking down the middle term into the three numbers who multiply to be positive 10x. And one of those factors, remember, must be the 2. So that must be then positive 2x and the 5, since we just found the value of b, who would be 5. Of course, a in our situation is played by variable x. Now, this allows me to rewrite this expression according to the formula that we earlier developed into a square of the sum, where the second term of the binomial is my b, the 5, and the first term is my unknown, the x. The other side of the equation will not change, and all this time it has been a 0. So my quadratic equation in three terms now collapsed into a square of a sum. And if you remember from algebra, the way to solve this kind of equation is by getting rid of this second power. One way of doing it would be to take a square root, both positive and negative, from both sides of your equation, because that will allow us to cancel the square root with power of 2. In that case, we only will have the binomial itself, x plus 5. On the other side, we will have a 0. I will write it as a plus 0, just to emphasize that when we have a different number here, different from a 0, still needs to continue solving this equation, keeping in mind that there would be either positive or negative results, whose squared would give you 0. So I will solve this equation for both positive and negative 0, just to once again emphasize that point. This expression now, equation rather, would turn into x plus 5 equals 0, and by subtracting 5, I will find the first value of x. I will continue then solving the other equation, where it could be rewritten as x plus 5 equals 0, and also will turn out to be negative 5. And we know that there are situations when quadratic equations have the same value for both roots. In that case, we know that vertex would simply intersect the x-axis at one point. So let's check it with the calculator. Here's the equation dialed. We will be able to plot it, and you see now vertex indeed intersects the x-axis at the only point right here, and you could verify that fact with using a table of your calculator. There will be only one value of x that has a corresponding value of y equals 0. That value of x would be minus 5, which is exactly the root that we identified. So our final solution is -5. Now I would like you to take a look at this equation and tell me how it is the same and how it is different from the one that we just solved. You might have already noticed that as the third term in this equation, we have a positive 12, which will make it different from the previous situation because there is no such integer who you could square, just like in this case, and receive a 12. So how do we deal with such situation? We will discuss that in the next example.